Assalamualaikum warahmatullahi wabarakatuh. Now, we will move to the application of redox reaction, which is the second application, the displacement of metal from its salt solution. Before we go further into displacement of metal from its salt solution topic, let us watch this YouTube video. During this experiment, we need to put the copper strip into a beaker, and the beaker will be filled with silver nitrate solution. In this reaction, we can see as soon as the silver nitrate solution filled the beaker, the color of copper strip becomes black. It is actually the reaction occur where silver ions receive electrons to form silver atom. The gray solid deposited on the surface of copper strip is actually silver atom. Another part of the reactions, copper metal, which is copper atom, release electrons to form copper ion. We can see the color of the solution changing from colorless to light blue. It shows that there are presence of copper 2 ion in the solution. The displacement reactions is a redox reaction. In order to understand the reactions of displacement of metals, we need to go through the electrochemical series. Referring to this series, the more electropositive metals are located at the higher position in the series. If we look at this series, potassium, calcium, and sodium, and also magnesium is the more electropositive metals. The reaction that takes place involves the transfer of electrons from metal atom to the metal ions. If we look at the arrow in this electrochemical series, we can see that the arrow is reversible. That means the reaction can occur when metal ions, receive electrons to form metal atom, or otherwise reversible, which is the metal atom release electrons to form metal ion. The more electropositive metals, easier for the metal atom to release electrons. The higher the position, it is easier for the metal atom to release electrons. Metal at the top of the electrochemical series are the stronger reducing agent. That means it is easier for the metal to release electrons and undergoes oxidation reaction. In contrast, the lower position of the metal ions in the electrochemical series, such as silver, copper ions, hydrogen ions, lead ions, the easier it is for the metal to receive electron. When the metal ion receives electron, it will undergo reduction reactions. Therefore, they are the stronger oxidizing agent. Now, let us look at the example of experiment between copper nitrate solution and zinc. In this reaction, zinc metal is more electropositive than copper. I just refer to the electrochemical series that we have mentioned before. The more electropositive metals, which is zinc, has higher tendency to release electrons and form metal ion, which is zinc ion. During this reaction, zinc atom undergoes oxidation reaction. Zinc atom is said to be a reducing agent. While on the other hand, the electrons will be received by the metal ion, which is copper ion, in the test tube. Copper ion with the charge of 2 plus will receive 2 electrons to form copper atom. When copper ion receives the electron, copper ion undergoes reduction reaction. Copper ions is said to be an oxidizing agent. If we refer to the electrochemical series, copper ion situated at the bottom of the electrochemical series. It is the second lowest metal ion from the series. Therefore, it is true that this metal ion, which is copper 2 ion, is a stronger oxidizing agent or a better oxidizing agent. Now, let us watch the animation of the experiment. Copper nitrate solution consists of copper ion. The presence of copper ion in the solutions shows by the color of the solution, which is blue. While zinc atom is a gray solid. During the reaction, zinc atom will release electrons to form zinc ion, while copper ion, which gives the blue color of the solution, will receive the electrons to form copper atom. So there are no longer presence of copper ion in the solution. That makes the solution turns from blue to colorless. While the solid form at the bottom of the test tube is brown in color because the copper ion has received the electron and undergoes reduction to form copper atom, which is brown in color. The summary of this reaction is zinc atom release electrons to form zinc ions. The product is zinc ions. Zinc atom undergoes oxidation reaction, while zinc atom is a reducing agent. The other half reaction that occurs is copper ion, that is blue solution, blue in color, receive electrons. Therefore, the concentration or quantity of copper ion in the solution decreases. Okay, because the copper ion has been changed to copper atom. Note that when copper atom is formed, it is in the form of solid. Copper atom, the color of copper atom is brown. So therefore, we know the brown solid deposited is actually copper atom. Copper ion is said to undergo reduction reaction, and copper to ion also is an oxidizing agent. Now, let us learn how to form an ionic equation for the reaction occur. As we know, the oxidation half equation is zinc atom release electrons to form zinc ion, while the reduction half equation is when copper to ion receive electrons to form copper atom. Refer to the number of electrons involved in both of these equations. The oxidation half equation released 2 electrons, while the reduction half equation consists of receiving 2 electrons. The number of electrons is equal, therefore we can cancel out the electron. After that, we have to combine both equations in order to form full ionic equation. Okay, so in this reaction, in this ionic equation, we can obviously see that zinc atom reacts with copper ions to form zinc ions and copper atom. I would like to enhance the changes in oxidation number during this reaction. We have seen that the reaction undergoes transfer of electrons. Usually, when the reaction involves transfer of electrons, it can also change the oxidation number of each element involved. First is zinc atom. The oxidation number of zinc atom is 0. When zinc atom changes to zinc ions, the oxidation number increases from 0 to +2. Increase in oxidation number is a oxidation reaction. While for copper ion, before the reaction, the oxidation number of copper is +2. During the reaction, copper ion receives electrons to form copper atom. It makes the oxidation number of copper decreasing from +2 to 0. It is confirmed that copper to ion undergoes reduction reaction. That is how we conclude the oxidation and reduction reaction in terms of changing in oxidation number. Now, let us check the observation and the corresponding inference for these reactions. In these reactions, the blue color of copper to nitrate solution becomes paler. Sometimes we say it as the intensity of blue solution decreases. It is because the concentration of copper 2 ions decreases. The second observation that we can see is brown solid deposited at the bottom of the test tube. It is because of solid copper is formed, or copper ions receive 2 electrons to form copper atom. We can also say it as copper 2 ion is reduced. The third observation in this reaction is the zinc plates becomes thinner, or zinc plate dissolve into the solution. It is because of zinc atom ionize to form zinc ions, or zinc atom release 2 electrons to form zinc ion. It can also be said as zinc is oxidized. So students, in order to improve our understanding on the displacement of metals from its salt solution topic, I hope you can answer this question and send it to my Telegram. Thank you.